All right, this video we're looking at the trends on the periodic table, and so as we go down on the periodic table or to the left or to the right or up on the periodic table, what happens to certain characteristics of the atoms? Do they become larger or smaller in radius? Do they want electrons more or less? We're also going to introduce some vocabulary to you, and so here we go, our trend on the periodic table. First one we've got is atomic radius. The radius is the size, the physical size of something, and so we're talking about the distance between the nucleus and the outermost electron. Okay, and so we can see our trend here is that across each row the atoms are larger in the left and smaller on the right. Atoms with more protons pull tightly on their valence electrons, resulting in a slightly smaller radius as you go to the right. Okay, and then as you go down, the presence of more energy levels causes the radius to increase as well. A visual, I think, would be helpful here. And so here is our way to visualize the atomic radius. As we go from left to right on a row, you can see that the radius decreases. We're adding more protons, but we're not adding any more energy levels. And so because we have more protons in the nucleus, that's a stronger magnetic traction for those electrons. And so it causes them to pull closer and closer to the nucleus. When we jump to another energy level, well, now we've got a whole another energy level, and so we've got a larger radius again. I think another good visualization would be this, where we can see this is a planetary model of the atom, where we can actually see the energy levels. Okay, and so you can see as I go from left to right, lithium, beryllium, boron, I'm adding protons, 3 protons, 4 protons, 5 protons. That's a stronger magnet. That's a stronger positive charge, and so it's going to pull those electrons closer and closer to the nucleus, all the way to neon, and then finally, boom, we add a whole new energy level with sodium and we get larger again. And so that's why you see this trend for atomic radius. It gets larger as you go down because you're adding energy levels. It gets smaller as you go left to right because you're adding protons, which cause a stronger nuclear pull, without adding any more energy levels. Okay, let's talk about ions. What if you were to gain or lose electrons? Well, when you lose electrons, you become a positive cation, and so are we going to get larger or smaller? It turns out that you get smaller. Well, that's the reason for that is that you're losing your entire outer energy level. We said that, for example, these alkali metals will lose their one outer energy level, their one outer electron, and thus their whole outer energy level. So when sodium loses this electron, it now has only 2 energy levels of electrons, and that's going to make it smaller. When we gain electrons to become a negative anion, we become larger. Why is that? Well, let's look at the halogens. These tend to gain electrons. This is going to gain 1 electron in order to fill its valence shell. And when it does gain that 1 electron to have a full octet, well, more electrons is going to cause those other electrons to kind of repel and swell out a little bit. And so when you add electrons to an atom to make it a negative anion, it's going to make the radius slightly larger. All right, let's talk ionization energy. First of all, the definition, it's the minimum energy needed to remove an electron from an atom. Okay, and so we're seeing how much energy does it take to take an electron off of the atom. Well, it increases as you go up and to the right. One of the reasons for that, well, it's just harder to get electrons off of smaller atoms because they're closer to the nucleus, and so that nucleus wants to attract them, and so it's harder to rip them off. Okay. Our noble gases have the highest ionization energy. They do not want to give up any electrons. Not only are they small, but they have a full octet, and so they're trying to hold on to those electrons because they're nice and happy with a full valence shell. So why is it harder to rip electrons off of the atoms as you go up and to the right on the periodic table? Because they're smaller, they're closer to the nucleus. It's hard to get electrons off of those. So the ionization energy increases as you go up and to the right. Metal activity or metal reactivity. you'll see it both ways. Metal activity is probably what I would use. And so when metals, we're talking about how much are they, what's their likelihood to react with things, okay? And so our metal activity increases as we go down and to the left towards francium. And we saw that in class where we saw the alkali metals reacting with water, and it became more and more vigorous of a reaction as we went down the group, okay? And so why is that? Well, if we look at our valence electrons, the electrons are farther away from the nucleus, easier to give away as you go down. And as you go to the left, you're closer and closer to fulfilling that full octet, in this case by getting rid of an electron. And so because they're so close to having a full valence shell, just by getting rid of one electron, well, it makes them more reactive. So metal reactivity increases as you go down and to the left. Our nonmetal reactivity, it's the opposite. And it's important to note, we don't include the noble gases in this trend because they're not reactive at all. And so our nonmetal reactivity increases as you go up and to the right towards fluorine, okay? And so the whole nonmetals are not even in this trend at all, okay? Why is that? Well, the halogens are really close to filling their valence shell, so they're going to do everything they can to get an electron from anywhere, and so that makes them very reactive and want electrons. It's also, they're smaller atoms here, closer to the nucleus, so the pull for electrons is stronger there, and so that's why it makes them more reactive nonmetals. Electronegativity, the tendency for an electron or for an atom to attract electrons in a bond. So we're talking about two atoms that are in a bond. How much are they going to pull on those electrons that are shared within that bond? The electronegativity increases as you go up and to the right, just like many of our trends. As you go towards fluorine, again, this is one where we do not look at the noble gases. We don't include them because they don't tend to make bonds. They at least don't have a very high electronegativity. Some of the noble gases you can get atoms to have a covalent bond with them, but very low electronegativity. They're not pulling on those electrons very tightly, okay? Now, again, these are trends, and so sometimes it's not always the case that it increases as you go up and to the right, and so you see some anomalies in here, but in general, our electronegativity increases as you go up and to the right towards fluorine, and we have this scale here. Electron affinity, very similar. It's the same trend. Really, the only difference is the definition of the term we're talking about. Electron affinity is just the attraction for free electrons, so not in a bond, but if there's an electron, say, passing by, how much does the atom want to grab onto that and hang on to it? Same trend, increases as you go up and to the left towards fluorine, and we don't count the noble gases at all in this one as well. So there are our trends. Now, you're going to get a long ways just by knowing the direction of the arrows for these trends, and so you need to be able to compare two atoms. So if I said, which has a larger atomic radius, scandium or vanadium? Well, you would say, I know that atomic radius increases as I go down and to the left. Scandium is farther to the left than vanadium. Scandium is then larger. That's one way, that's how you're going to need to reason through some of this. So atomic radius increases as you go down to the left towards francium. Ionization energy increases as you go up and to the right towards helium. Metal reactivity increases as you go down to the left towards francium. Non-metal reactivity up and to the right towards fluorine. Don't count the noble gases. Electronegativity, same thing, towards fluorine. Don't count the noble gases. And electron affinity, same thing, up and to the right towards fluorine. Don't count the noble gases. Those are some of the trends on the periodic table, and there you go. We'll revisit some of those in class.